Welcome to solverfy.
Okay, so let's suppose, as question 5 wants us to, that we have acetic acid and aniline in a beaker, right? Or in a separatory funnel, as it would be. And the question is, write a flow chart to separate by extraction this mixture. Okay. Now, what these are done by is a series of acid and base reactions. And the reason for that is as follows. If we protonate aniline to the positively charged ammonium, right, this is water soluble. When it is not protonated, regular aniline is organic soluble, right? It's nonpolar. Maybe I should just write that. All right, polar and nonpolar. Polar, which we know to mean soluble in water or other polar solvents, and nonpolar. Okay. Likewise, carboxylic acid or acetic acid, right? In either form, be it protonated, right, is going to be polar, and deprotonated with a base to form the carboxylate, very polar, right? That is to say that deprotonated carboxylic acid becomes very polar and is not soluble at all in organic. Okay, so let's say organic solvent and then aqueous solvent, right? Protonated aniline has low solubility in organic and good solubility in aqueous, right? But when it's not protonated, it has good solubility in organic and low solubility in aqueous. Carboxylic acid is always low solubility in organics, but good solubility in aqueous. And when it has been deprotonated, it has very low solubility in organics and very good solubility in aqueous, right? So the more polar something is, the more soluble it is in water and the less soluble it is in organic, and vice versa. So how can we separate these? Well, we're going to take advantage of this set of rules, right? So if we treat this with base, for example, let's say sodium hydroxide, what's going to happen to our species? Well, our carboxylic acid will become deprotonated, forming the sodium salt that is very polar, whereas nothing will happen to our aniline because sodium hydroxide is not strong enough to deprotonate an amine, and it will definitely not become protonated because there's not an excess of H+. At this point, we can add organic solvent and add water if we haven't already. And assuming that the organic solvent we've used is, say, diethyl ether, which will be lighter than water, we will get the following. 2 layers. Water with our very polar carboxylate and our ether layer with our aniline. And then we simply need to extract water layer. right, using a SEP funnel. To end up with two separate containers. Our aniline in ether and our carboxylate salt in water.